Contact force. The force applied to the object by making physical contact with the object is called the contact force. Examples of the contact forces are tension force, normal force, air resistance, spring force, applied force. Here, no field is linked for the force to be applied. The force is exerted on the other object only by means of physical contact. Non-contact force. The force applied to the object from the distance without touching it, or by exerting a physical force on it is called a non-contact force. Examples of non-contact forces are gravitational force, magnetic force, electrostatic, nuclear force. The field is linked in all these forces and acts on any object present in this field. Magnetic force. In presence of an external electric field, the positive and the negative charge carriers inside the conductor tend to align themselves according to the external field applied. This results in small drifts of the charge carriers. Due to this mobility, the magnetic field is set up inside the conductor. The particle inside the material drifts in a helix path. The magnetic force is experienced perpendicular to the motion of the particles in a magnetic field to keep the spins aligned in the same direction without affecting the orientation. The magnetic force is given as by the relation. The magnetic force depends upon the charge of the carrier, the velocity of the particles, and the external field applied. Subsequently, the magnet, which is already a magnetized material, has its own tendency to produce a magnetic field around itself because of the existence of the magnetic dipole field inside the magnet even in the absence of any external supply. The dipole is a separation between the positive and the negative charge of the particle due to the presence of an external field. Why magnetic force is a non-contact force? The magnetic force is basically of two types: the attractive force and a repulsive force. If the object having ferromagnetic characteristics is placed in this field, then it will experience the attractive force on it. For the object with diamagnetic behaviors, when placed in a magnetic field, the repulsive force will come in an act that tends to push the object away from the magnetic field region. The dipoles inside the magnetizing material are arranged in colonies having specific spin and directions. When it is influenced by the external field, all the colonies of dipoles will get aligned in a certain direction by changing their spin and alignment so as to build the force of attraction on the material to pull it closer to it. The force is exerted on the material only when this material is placed in the magnetic field region produced by the magnet. The magnetic field is theorized as flux lines passing from one pole to another, showing one pole as attractive and another as repulsive. Due to the presence of two different poles having characteristics of attraction and repulsion, magnetic field lines are thought to be in concentric circles emanating from the repulsive pole and emerging into the attractive pole of a magnet. Any object with ferromagnetic or diamagnetic characteristics will show a strong force of attraction or repulsion when placed in the magnetic field. The force experienced on the objects is without being in close contact with the magnet, but only on introducing the object in the magnetic field of the magnet. Hence, the magnetic force is the non-contact force. How do you know if a force is a contact force? A contact force is a force exerted on one system when another object applies a physical force on it and some work is done while doing so. For example, consider a man pushing a box of load 50 kilograms. The box will be displaced only when the man will push the box away from him. The work done to displace the box at a distance, x, from the original position is given as. The force applied by the man for pushing the box is a contact force. The frictional force is another example. A car doesn't T-slip when accelerating is due to the frictional force, which is also a contact force between the tires and the metallic road. The contact force is only when one body exerts a force on another body by coming in physical contact with it. How is the magnetic force a non-contact force? There is a force of attraction and repulsion between two different ends of the magnet, and that is felt across the region encircling it. The greater the size of the magnetized material or a magnet, the greater will be the area of the magnetic field region produced by the magnet. The strength of the magnet depends on the magnetic flux density per unit cross-section length. This magnetic force is a fundamental force in nature that is experienced by two oppositely charged embedded particles in the material, and the force is observed only when the object is present in the magnetic field region produced by the magnet without actually coming in physical contact, while no work is done during this process. When any material is introduced in the magnetic field region at a distance away from the magnetic poles, the unpaired electrons from the compound of the material will start reacting to the external field. The positive pole of the magnet will try to attract the material if the material is enriched with more unpaired electrons, and will repel away if there is a deficiency of the electrons. If the magnetic force would have come in the scenario only when the magnet was brought in physical contact with the ferromagnetic material, say for example an iron bar, then we could have said that the magnetic force is a contact force, but it doesn't happen in this way. Even if we introduce the iron bar in the magnetic field produced by the magnet placing it at a certain distance away from the poles of the magnet, it will also then exert a force on the iron bar that tends to attract an iron bar towards the magnet. The unpaired electrons from the iron bar will experience the force of repulsion from the negative pole. How does a magnetic force act without direct contact? When the magnetizing material is placed in the magnetic field region around the magnet, the dipoles inside the material will experience the magnetic force and will orient themselves in the direction of the field applied. This depends on the magnetic property of the material, permeability, and the magnetic flux penetrating through the material per unit cross-sectional area. Let us consider a simple example of a bar magnet and an iron nail. When the iron nail is placed in the field of the bar magnet, the nail will attract towards the north pole. The same will repel when held at the south pole of a bar magnet. Whereas, no forces of attraction or repulsion will be observed on the iron nail when it is placed a little far away from the magnetic field region developed by the bar magnet. This is because the intensity of the magnetic field exists only in the magnetic flux region and purely depends upon the density of the flux passing through a unit area. Beyond it, no material will show any attraction or repulsion towards the magnet. When the object is present in the magnetic field region of the bar magnet, the positive pole of the bar magnet will exert a force of attraction on the negative charges in the material and vice versa. Both the forces are equal in magnitude, and hence the iron nail tends to attract the positive pole of the magnet. This is how the magnetic force acts without actually being in contact with the objects, and exerts a force on the object when present in the magnetic field surrounded by it. Some examples of magnetic force. The deflection of a magnetic needle in a compass, the magnet fixed on the door of refrigerators, and inclination of the magnetic needle inclinometer used to study the stratigraphy of rock beds, the magnet used in electric motors that results in the rotation of the motor, in speakers, microphones to produce an audio effect, in fans to repel the stator away from the rotor to increase the speed, etc. Frequently asked questions. Is there a magnetic force between the charged particles? The moving charges are associated with the magnetic field due to their angular momentum and spin. The charged particles do show magnetic forces between them too. Same like two bar magnets, the like charges will repel away from each other, and unlike charges will attract. What are some examples of a non-contact force that we often come across? The non-contact forces are exerted by one body to another without coming in physical contact. The raindrops on the earth, the objects falling on the ground when dropped, the attraction of metal on the bar magnet without physical contact, charging of hair, and attraction of paper bits, a ball bouncing on the ground, wither leaves falling on the ground, deflection of a magnetic needle are few examples of a non-contact force. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. scientific calculator, and many more other tools.